Let's look at an application problem to see how Newton's second law can be used to find the thrusting force provided by the rocket motor of a toy rocket. Since there is an acceleration of 16 meters per second, Newton's second law applies here. Let's look at the forces on the rocket. First of all, there is the gravitational force or the weight force by the Earth from the center of the Earth on the center of gravity of the rocket, or F sub W, is m mass times the acceleration of gravity. This is a downward force. There is a rocket motor, but the rocket motor is part of the rocket, and a body cannot exert a force on itself. F sub m, as depicted here, is the third law reaction force to the rocket motor force, which is downwards. F sub m, the reaction force, has the same magnitude as the rocket motor force, but it is directed upwards. We simplify the force diagram by making the free body a particle at the center of gravity of the rocket and depicting all forces concurrently on that particle. That would be the motor force acting upwards and the weight force acting downwards. The acceleration must be in the direction of the total force. And here we see that the acceleration is upwards. The mass is 228 grams. The magnitude of the acceleration is 16 meters per second, and the magnitude of the acceleration of gravity is 9.80 meters per second. The unknown. We wish to find the magnitude of the reaction force to the motor force. The equation is Newton's second law along the y-axis, or the net force in the y direction is equal to mass times the acceleration in the y direction. Substitute and solve. F net of y is plus the magnitude of the motor force F sub m minus the mass times the acceleration of gravity's magnitude, g, and that on the other side is mass times a sub y. Rearranging, we get that the reaction to the motor force F sub m is mass times the magnitude of the acceleration of gravity plus the mass times the y component of the acceleration. We factor out the m for simplification, and then we substitute. We must put in standard units for mass, so we must convert the grams to kilograms. We get 0.228 kilograms times 9.8 meters per second plus 16 meters per second. This gives us three significant figures that the reaction to the rocket motor force is 5.88 newtons. The end.